Greetings. Welcome to Machine vs Mathematics channel. Sometimes we will be having jet transformation of a discrete time sequence. And ROC is not specified directly. That means we may have indirect information about region of convergence. Now in that scenario, how do we find that time domain signal or time domain sequence? Yeah, so the same situation asked in GATE ECE 2007 for $2. You see the jet transformation of a sequence is given like this: x of z is equal to this one. Now it is given that ROC of x of z includes the unit circle. Yeah, so this is like indirect data he gave. The value of x of 0 he is asking us now. Now you have four options. Now anyways, x of n jet transform is x of z. Okay. Now we should be able to take inverse jet transform, and after taking inverse jet transform we must be able to find x of 0. Now x of z is this. Now you tell me this one here. So given x of z is equal to 0.5 over 1 minus 2 z power minus 1. This is of what form? See, actually what we have is this. For example, you have 1 over 1 minus a multiplied by z power minus 1. Now if I take its inverse, jet transform, then what must be the time domain signal? Yeah, for this compact form in the jet domain, either we get infinite duration causal sequence or infinite duration anti-causal sequence. Yeah, because we have a pole at z equal to say a. Yeah, so ROC must be specified, right? If ROC is not specified, I cannot determine this time domain signal uniquely. Yeah, otherwise we have like this. If you have 1 over 1 minus a z power minus 1 and ROC is given modulus of z greater than modulus of a, then what must be its inverse quantity? So as ROC is exterior of a circle whose radius is a, or we have pole at a, then in that case you will be having time domain sequence as a power n u of n. Okay. Now for the same compact jet transform, if ROC is mod z less than modulus of a, now in this scenario you will be having time domain sequence as anti-causal sequence, infinite duration anti-causal sequence. See, we have same compact form in either case, but because of difference in their ROCs, we have corresponding signals in the time domain. So as we know, this jet transform is there like this, but jet transform plus ROC will decide uniqueness of a time domain sequence. Now now this quantity x of z is equal to this is of this form, right? Is of this form. So we must be able to decide whether we get this form in the time domain or this form in the time domain. So who is going to help you out? So ROC is now directly specified. Indirectly we have like this: ROC of x of z includes the unit circle. Okay, so therefore we will work it out like this. Let me take another page. So we have x of z like this. So what do you have? So x of z. So what is given to you? So given to us is this 0.5 multiplied by 1 over 1 minus, this is 2, right? Okay, 1 minus 2 multiplied by z power minus 1. Yeah, so in place of say a, you have 2. Now which one do I get? Now we have two options. Now how do we get this? You see, half multiplied by 2 power n u of n. Either we must get this one or we must get like this, half multiplied by minus 2 power n u minus n minus 1. So answer must be either this or this. Now we have to decide which is the correct option. Now as we have pole, now this indicates that we have pole at say z equal to 2. Say you have pole at z equal to 2. Now, so what can we say? So therefore ROC may be either z greater than 2 or z less than 2. That's it. Because see, if you want to get this one, then ROC must be this. If you are expecting this one, then ROC must be this one. Clear? Now, as we have, see, there is no confusion here. As we have ROC of x of z includes the unit circle. So therefore, includes the unit circle means radius is 1 over there. So we could say like this, as 1 is less than 2. So we can select this fellow. How? For example, you see, let me take my z plane. So real z and imaginary z is this. Say this is my unit circle. Okay, this is my say unit circle. Now let me draw a circle, say passing through this pole at 2. Okay, and this is my say circle with radius 2. With radius 2 we have. Now this is my unit circle. Where is our unit circle? We have unit circle. This one. This is our unit circle. So ROC must include unit circle. So what do I do now? How can I include unit circle now? If I take modulus of z greater than 2. If I take modulus of z greater than 2 like this, then we cannot include unit circle. But in the given question we have ROC must include unit circle. So therefore I can take like this. So this, see, this blue dots is intersecting with this unit circle. Now we could say this ROC is including this unit circle. Yeah. So therefore we could say modulus of z less than 2 is correct. Okay. Now if that is true, now you have this question, half 1 minus 2 z power minus 1. Now if I take its inverse, so as we have this, so there is no second thought, you have this one. So 2 power n u minus n minus 1. We brought this negative sign here, and that's it. This is what your signal in time domain. So our time domain signal is anti-causal sequence. So this is 2 power n u minus n minus 1. Alright, so we have this. Now what is he asking? He is asking us to find x of 0. See, the value of x of 0 in time domain. So therefore I'll try to find it out. So x of 0, put n equal to 0, minus half 2 power 0, and this is what u of minus 1. Okay, n equal to 0, u of minus 1. And what is u of minus 1? U of minus 1 equal to 0. So therefore half multiplied by 0 is 0. So therefore x of 0 is 0. Option B is correct. Yeah, but 2 marks, right? So there is no big deal in solving this this question, because you see u of n is like this. If I take u of n, so as my u of n is a causal sequence, n equal to 0, 1, 2, 3, so on. So we would get, so we have samples like this. Okay, so we have samples. This is what my u of n, right? So on. This is my u of n, and I don't have any samples here. So on. So this is my minus 1, minus 2, so on. So u of minus 1. So u of minus 1 equal to 0. Otherwise, this fellow, this like a power n u minus n minus 1, how can you draw this? So this is from minus 1, minus 2, minus 3. So you have life from minus infinite to minus 1 like this. So we have life up to minus 1, and from 0, 1, 2, 3, so on, you have no life for your sequence. So therefore, finally we can conclude x of 0 equal to 0. So that's it for today. Okay. So thank you and bye.